Hi, I am Atanu. Here you learn polygon in geometry. First we learn what is polygon. It is the closed two-dimensional figure which form by the three or more straight line. Let's understand this definition. If three line produce a closed figure, we know this is a triangle. So triangle is a polygon, and this is also example of polygon. The special name of this polygon is pentagon. Is it polygon? Not polygon. Why? Because one side has a curved line. So this is not the straight line, it is the curved line. Is it polygon? Yes, this is a polygon. Now we learn why the polygon should be 2D geometry. If we draw in the 3D space like this figure, then dotted line indicate this portion of the line is under the plane XY. This is the XY plane. If you try to observe this, now look. So this portion, the dotted portion, is not lie in the XY plane. It is lie in the different plane. That is the reason this is not a polygon. Reason is that it is not lie the all straight line in the same plane. Next we learn type of polygon. First is regular polygon. If the all line symmetric, then we can say it is a regular polygon. This is equilateral triangle. Square, it is also a regular polygon. Regular pentagon. Regular hexagon. Regular trapezium. These are the some example of the regular polygon. Next we learn the irregular polygon. If one or more sides of the polygons are not equal, then we can say it is the irregular polygon. Let's take one example. This is the scalene triangle. Irregular pentagon. And one thing you must remember, that for the all regular pentagon, all inside angles are or internal angles are same. Clear? But here the internal angles are not same. Next we learn concave polygon. When any of the interior angle of the polygon is more than 180 degree, then we can say it is concave polygon, because one of this internal angle is more than 180 degree. Suppose it is x, if we consider it will be more than 180 degree. And if all internal angles are less than 180 degree, then it is said the convex polygon. Now we learn different formula of angle of polygon. Let's consider one polygon. If we connect the diagonal of the pentagon, in how many triangle we get? 1, 2, 3. But here how many sides are there? 1, 2, 3, 4, 5. And number of triangle is equal to 3. So what is the relation between the 5 and 3? 3 is equal to 5 minus 2. Now if we consider for any polygon with the number of side is equal to n, the number of triangle will be what? N minus 2. And we know that angle sum property of the triangle, all interior angles sum is 180 degree. So how many triangles are there? 3. So total interior angle of polygon is equal to n minus 2 into 180 degree. Degree. So this is one formula. Sum of all interior angle of polygon with n sides is equal to n minus 2 into 180 degree. Yeah. Why? Because look at this, for the triangle 1 the sum is these 3 angle, and for the 2 sum is again this, and for the 3 this. So it cover all internal or the interior angle. Clear? Now we find out the formula of sum of exterior angle. Let's consider a polygon So what are those exterior angle? These are the exterior angle. Now how we can find out the sum of this exterior angle? If we remove the all line, then look at this. Let's consider this irregular pentagon as a polygon. So these are the exterior angle. How we can find out the sum of this exterior angle? 5 and 1 side. What is the exterior angle? This 5 and 1. This one is a similar angle. Then between 1 and 2 is the, again it is similar. And then between 2 and 3 this angle, and between 3 and 4 this angle, and between 4 and 5 this angle. So we get a total angle that is 360 degree. Here we learn sum of all exterior angles of any polygon, like in this example it is pentagon, is 360 degree. Clear? Next we learn each interior angle of any polygon is, we have already learned sum of all interior angles of a polygon with the n side is how much? N minus 2 into 180 degree. Now if it is divide this sum by n, why it is n? Because the number of side equivalent to number of interior angle. Now look at this pentagon. Here how many lines are there? 1 2 3 4 5. And how many interior angles are there? 1 2 3 4 5. So this is a formula. Next we learn each exterior angle of a regular polygon equivalent to, we have already learned that sum of the all exterior angle of any polygon is 360 degree. So we have to divide 360 degree by n. Here also number of side equivalent to number of exterior angle. So this is another formula. And here n is number of side. Now we learn the number of diagonals in polygon. It is equivalent to n into n minus 3 by 2, where n is the number of sides. Let's consider one triangle. Here n is equal to 3. So diagonals of triangle is equal to how much? 3 into 3 minus 3 by 2, that is 0. We can't draw the diagonals. For getting the diagonal, the sides of the polygon should be more than 3. So let's take one example. This is the quadrilateral. So here n is 4. So diagonals is equal to 4 into 4 minus 3 by 2. So this is 4 by 2, that is 2. Now draw the diagonals. This is one diagonal. Next we learn the different shape name of the polygon. The polygon with the 4 sides is called the quadrilaterals, and there are special quadrilateral also there. So first is square. Before that we take one example of the quadrilaterals. Let's take one example. So this is a quadrilateral. Square. Next example is rectangle. Next is rectangle. Next is parallelogram. Next is rhombus. Next is kite. Next is trapezium. This is the example of trapezium. And one thing you must remember, for the polygon, just consider a polygon. If you consider any internal or the interior angle, and this is interior angle, for example I, and exterior angle E, you must remember I plus E is equal to 180 degree. They are the linear pair. This is the end of this video. Thank you for watching this.